So this is gonna be me going very fast. This is a project I did which was just for fun while I had some free time. So you can call it professional development if you want, or just fun. Um, but it comes from my interest in programming languages. So I kind of like programming languages as a hobby. Um, I've worked in them a lot. The big quote here is a language that doesn't affect the way you think about programming is not worth knowing. Okay. And I'm going to really rapidly go through Rust, Elixir, and Idris 2. And what I did in this project was take the interchange part of high throughput executor, which is this bit in the middle. Tasks come from the left from the DFK or from a compute endpoint into the interchange, and they go out to worker pools. And for this talk, we can model it as the network on the bottom, then ZMQ messaging, Pickle and JSON message formats, and the high throughput executor on the top. So the first language is Rust, and Rust describes itself as a language empowering everyone to build reliable, efficient software. And it usually targets the traditional area where you would use C. What they add on is a really rich type system and an ownership model to get more memory safety, more thread safety, so you get rid of bugs at compile time. If you're using, for example, Pydantic, the back end of that is written in Rust, so you're possibly already using it. Static typing, not particularly new anymore. Parcel's been using this for 3 or 4 years now. Um, Pretty simple. You stick type annotations on stuff, and then tools can tell you if you're using those variables wrong. One of the things that Rust adds onto this is an ownership model, which is trying to make memory and threads more safer. So everything has a piece of code that is its owner, and when that owner is done with it, you either have to free it or you have to transfer to someone else. So there's no garbage collector, even in a garbage collected language. So in Parcel, for example, memory usage, as we heard yesterday, at scale is important. The garbage collector isn't just going to do this for you. I did this in Rust. I thought it would be much faster. Um, Parcel perf gave basically the same results for the Rust and Python interchange. As a spoiler for maybe Yadu's talk later, it's always logging. I went off on a massive rat hole just looking at different factors there. So you can click on that link later if you want. And the other thing that was interesting was that it just got me thinking about our protocols a little bit more and picking holes in our protocols. Even Kevin went and fixed some of the holes that I found there. So that was pretty good. The next language, Elixir, it's built on top of Erlang. So Elixir is a dynamic functional language for scalable and maintainable applications built on a language used to build scalable real-time systems with high availability. If you're using Globus Compute, your tasks go through a component called RabbitMQ that is built in Erlang. So all the concurrency in Elixir is done with lightweight processors. You can have per machine up to about 200 million. They send messages to each other. It's reminiscent of object-oriented programming from the 70s, or even Greg's talk talking about the actor model, that kind of stuff as well. And one thing that's interesting to me is the failure model. You make your processes do one thing only. If something goes wrong, you terminate. You don't catch exceptions. You accept that recovery is hard. You just exit. And all the other processes have to expect other processes to fail in that way. Not doing that in Parcel has been one of our biggest sources of hangs, I think. So that's something to learn. And my implementation was terrible. And really unscalable. And what it made me realize was that Parcel doesn't have any theory or mechanism on how to slow down with back pressure. And some of that led me to thinking about the billion task Parcel talk that I did in the community call earlier. So maybe the right thing to have done would have been to replace the entire worker pool model rather than just the interchange and use Erlang Elixir messaging over the whole cluster instead of just replacing the interchange. And the final language is called Idris 2. This is the most insane one. It's a research language, has a really strong type system. Your types start looking like they're propositions or theorems about your program. And the type checker is then proving that your program is correct mathematically somehow at compile time. It's a research language. I had to build my own interfaces to the operating system, to libzmq. I wrote my own pickle encoder decoder, which is awful. And then on top of that, the actual interchange logic. So one of the examples of what you might do with a strong type system, when you open a file descriptor in C, you get back an int. In my implementation, what you get back is a typed file descriptor that says this is a file descriptor for a file that you can read from, or this is a file descriptor for a ZMQ socket that you can poll, but you can't read from it directly. And that kind of stuff gets checked statically at compile time before this goes to users. And the last cool thing this has is a thing called linear types, which helps you model resources and state. It's a little bit like what happens in Rust as well. And it helps you do type checking on if you've got memory allocations, you can't just share that stuff everywhere and you have to free it. File descriptors, you have to make sure they're closed correctly. And at a higher level, for example, parcel tasks. In the interchange, I don't ever want to lose a task and forget about it. If I have a task object in the interchange, the only way I delete it is if I say, all right, I definitely don't want this task. And I want to force this protocol that we might put the task in a queue maybe, and then it goes to a worker, and then it becomes a result, and then it goes back to the submit side. And you can start enforcing stuff like this in the type system and check that whatever the code path we follow, this kind of protocol gets followed. So in conclusion, I learned a lot of stuff. I had a lot of fun. There's a lot of style in other languages which you can learn, and that's already influenced how I've done some stuff in the Python version of Parcel. There's a bunch of tidy up issues I made while working on this. So if you're interested in getting started in HTEX, some of those issues that you'll find in the issue tracker would be interesting maybe for you to have a play with.